It was sitting right here. She got mad because her stupid chair was stolen.
Well, this one's a little dirty now.
Dirty. Ooh, my
The shoes on?
Yeah,
Alright,
I got
the
shoes.
next unit, we're going to do pieces of chapters 10 and 11, so we're talking about hypothesis testing. Today we're really just going to focus on meaning and language, so we're really not doing much math today, just writing sentences. Then we'll get into our testing. We are going to do the testing primarily on the calculator, so we'll talk about how to do it by hand, but pretty much everything will be done on the calculator in this unit. So, first, just to get you thinking, a friend wants to play a simple coin flipping game. If the coin lands heads up, you win. If it lands tails up, your friend wins. Suppose the outcome of 5 plays is 5 tails. Do you think your friend is cheating?
Yeah.
You guys don't trust your friends.
No.
Okay.
Not that much.
He has a weight on the head.
So what's the probability of getting this? 5 tails in a row.
1.5 times to the
1/2 times 5 or multiplied 5 times or to the 5th power. So we get 0.0312. So, is it impossible? No, there's a 3% chance this happens. So if you and your friend did this 100 times, you would expect 3 times to have this outcome, so it can happen. Is it likely? No.
It's unusual.
Right. Possible, but unusual. Okay, so we would be very suspicious if our friend were cheating or not. Maybe it depends on the kind of friend you keep, I don't know. But the question is, like, how unusual is unusual enough that we would think they were cheating? Okay, that's kind of the motivation for where we're going with this. A hypothesis is a statement regarding a characteristic of one or more populations. So, for example, in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So their hypothesis is the percentage has changed. Okay. Second one, according to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. So their hypothesis is the length of the call has increased. So their hypothesis is just what they think is happening. When we do this, we are going to be making a hypothesis and testing the probability of that hypothesis being true. Now, one thing to note, if I have the data for how many people volunteer their time for charity work today, do I need to make a hypothesis? No. If you know the numbers, there's no point for hypothesis testing. So if you know the population data, we don't need this. This is for a situation where I have data from a sample and I'm trying to make a guess about the entire population based on that. So the hypothesis testing is the process that we are going to use. When we go through this, we are going to have to do a couple different things. We'll make a statement regarding the population, we'll look at our data to test the statement, and then we'll make a conclusion, analyze if this is true or not. Today we're going to talk about 2 components, a null and an alternative hypothesis. The null hypothesis is H sub 0. So that is like what we believe to be true. The alternative is H sub 1. That's the one we're trying to prove in contrast. So like when we looked at, okay, use that example. So if I said last year the average stat exam score was 85%. I believe this year it's higher. Okay, your null is like what's happened in the past or what evidence I already have. So what would my null hypothesis be here? The first half, that the score is 85%. That's my null. Alternative is what I think might be true now. So my alternative would be that this year is higher than 85%. All right. When we do this with the null hypothesis, it is assumed to be true unless the evidence proves otherwise. So we are not actually proving if the null hypothesis is true or false. We are assuming that's true. And we're seeing, can I prove that it's not? So we assume it's true unless we prove otherwise. When we do our hypothesis testing, there are 3 different potential setups that we might have. There's basically not equal, less than, and greater than. A two-tailed test is not equal. So it might be the null is that my mean is equal to 85%. The alternative might be the mean is not 85%. Okay, that's two-tailed because it could be more, it could be less. There's 2 different options. We're just saying it's not the same. Did you get it?
Yep.
Okay. Left tail is less than, going to the left. So it might be, my null is that the mean is 85%. The alternative, the mean is less than 85%. Right, that's considered left tail because if you think about an inequality, it's going to the left. The last option, right tail, is going to the right. So your null might be the mean is 85%. I don't know why I keep writing 81. And the alternative, the mean is greater than 85%. So 3 different possibilities. Do you guys understand the term two-tailed, left-tailed, right-tailed? Notice on all of these, they have something in common. No matter what kind of test you're doing, the null hypothesis is going to be something equals something, always. The alternative is your less than, greater than, or not equal. All right, so we are going to read some scenarios and see if we can write the hypothesis. So those first examples. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes the percentage is different today. So what would my null hypothesis be? 62%. It's not a mean here, so think of it like percent is p. So the null is that my p is equal to 0.62. So my alternative, h sub 1, we think it's different, so p is not equal to 0.62. All right, is this two-tailed, left-tailed, or right-tailed? Two-tailed. If I ask your parameter is the thing being tested, which is p here. It's basically your variable. Am I talking about a proportion or a mean, or it could be a standard deviation, whatever we're looking at, a variable. So B. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. researcher believes the mean of the call has increased. So what's my alternative? Or sorry, my null hypothesis. The mean equals, it's not a percent here, it's just minutes, so we'll just do 3.25. It is the mean, because it did use that word, the mean, so that's why I'm using mu. The alternative, we think,
That is
Greater.
greater.
Right.
Right-tailed, if you drew a graph, you'd be shading to the right. What's my parameter here? Right. C. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has increased. So what's my null? Right. Standard deviation would be sigma equals 0.23. Then the alternative would be decreases less than 0.23. So left, right, or two-tailed? What is my parameter here? Any questions there? The second component that we need to talk about today is error. So there are two types of error. We know that no matter what, we're not going to be perfect, right? We're going to make a conclusion and we hope it's right, but there is the potential that we make the wrong conclusion, right? I might think that my evidence is telling me the alternative hypothesis is true and it's really not. Or I might think the alternative is false and it was really true. So those are the mistakes you can make. Alpha is considered the probability of a type 1 error. Type 1 is when you reject the null, but it's actually true. So it would be like me saying, okay, if I reject the null, that means I think the percentage is different today, but it's not. Okay, so how I remember this, in type 1, you conclude H1 is true. But it's not. It's an error because we made a mistake. So I remember it, type 1, your conclusion is H1, your alternative hypothesis. But it's an error, so we know we made the wrong decision. Type 2 error is you don't reject the null, but the alternative was true. So in type 2, you conclude the null is true, but it's not. Okay, so errors, you make the wrong choice. Type 1, you conclude H1. Type 2, you conclude the alternative. Or, sorry, you conclude the null, but it was the alternative. Alpha we'll talk about a lot as we go through this unit. Alpha is the probability of type 1 error. So you'll see that frequently. We talk about type 1 a lot more than type 2. So what we're going to do now is just write a sentence. For each of the following claims, explain what it would mean to make a type 1 error and a type 2 error. So in 2008, 62% of adult Americans regularly volunteer their time for charity. A researcher believes the percentage is different. Okay, so look back at our example where we wrote the hypothesis for this So example 2A. Type 1, I told you you conclude H1. The ones go together. What was H1? So we conclude that P was not 0.62 because we concluded H1. But it does. But the P is 0.62. We made a mistake. We concluded H1. Type 2. So in type 2, I told you you conclude H0. So that would be we conclude that P is 0.62, but we should have gone with the alternative. But it does not. Take a second and try the second one. Look back at 2B for your null and alternative if you need to. Is when you conclude H1. So in that, our H1 was that the mean was greater than 3.25. So we conclude mean is greater than 3.25 minutes, but we're wrong. So we just say, but it is not. Okay, or you could say the mean equals 3.25 because it should have been the null hypothesis. Okay, so type 2 is when you conclude the null. So we conclude the mean is 3.25, but it was really the alternative. But actually, the mean is greater. Okay, that's a slight difference on A. We said, but it wasn't equal to. That's because the alternative was not equal to. Here, the alternative was greater than, so it should have been greater than. All right. Any issues with those? In general, type 1 and 2 errors are related. We are never accepting the null hypothesis. When we make a conclusion in the next few days, we're not going to say the null hypothesis is true. We're not actually trying to prove the null hypothesis is true. We're assuming it's true and seeing if we can prove it false. So our conclusion will either be that we proved it's false or we could not prove that it's false. Is not proving it's false the same thing as saying it's a true statement? No, it's different. It's just saying I couldn't prove it was wrong. Did I prove that it was right? No, I just failed to prove it wrong. Okay, so just be careful of that. Our wording, we'll talk a lot as we go through there. We'll say we do not reject it rather than saying we proved it to be true. So we're just going to practice that wording, and we will do a lot more of this when we actually get into our testing. So according to a study, blah, 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 it's the same one as the phone call example. So remember that our null hypothesis was the mean was equal to 3.25. The alternative that was that the mean had increased. Suppose that the evidence indicates the null should be rejected. How would we word the conclusion? So we would say, there is evidence to conclude. If I reject the null, that means I'm going with the alternative. So the mean phone call length is greater than 3.25 minutes. just saying I had enough evidence. If I rejected the null, I have enough evidence to conclude that the mean is greater than 3.25 minutes. The alternative, or the other one, suppose the evidence indicates the null hypothesis should not be rejected. If I don't reject it, does that mean I proved it true? No. It just means that we didn't have enough evidence to prove it false. We'd say there is not enough evidence to reject the null. So we can't prove the mean call length. Is greater than 3.25 minutes. Okay. Doesn't mean I proved it was 3.25, it just means I failed to prove that it's bigger than 3.25. So this is really just getting used to how hypothesis testing looks, getting used to some vocab, the null and alternative, type 1, type 2 errors. So your homework is pretty straightforward. It's just asking you to write some sentences. Am I looking for sentences word for word like this? Absolutely not. But you should be able to explain your conclusion. So I'm going to go ahead and give the homework out. Just like we have been doing, it's the whole packet for chapter 10. So you can only do 10.1, which is like 5 questions. Some of them have A's and B's. So you can start this, and then I will also hand back tests so you can look at it.